Hello and welcome to today's lesson. We're looking at our area and volume unit 4, lesson 2, and in this lesson we are going to calculate the volume of a cylinder. Now, when we're looking at the volume of any shape, we have to remember that volumes are three-dimensional. So there's not just a length and a width to them, but there also is the height. So we're looking at our three-dimensional space and finding that three-dimensional space for a cylinder. So when we look at our length and width, which is our normal base shape, our base shape here is a circle. So when we're looking at the volume, we're trying to fill the space with a bunch of circles based on the height of the object. So when we look at building the formula for volume of actually almost any shape, we're always looking at volume equals base times height. Now we have to be careful. Capital B means area of the base. And capital H means the height of the object. Okay, so once we find the area of the base, we can multiply that by the height of the object, and that gets us our volume. So if we're looking at the volume of this cylindrical shape that we have here, the area of our base is a circle, so we need pi r squared, and then times the height of the cylinder itself. So now we have our formula built out, we just need to plug in the pieces and simplify. So our radius is 3, so we have 3 squared pi times the height of our object, which is 11, and then our units is going to be centimeters cubed because we've got our 3 dimensions of space. 3 squared is 9, 9 times 11, and in this case we're going to keep it in the we are going to keep it in exact form. So the area or volume of this cylinder is going to be 99 pi. Now, what happens if we're dealing with an oblique cylinder? And we can use these stacks of quarters to really talk about what happens when you make something an oblique shape. So when we take this stack of quarters and we tip it on its edge, we are changing the angle that we have here. We've got a right angle in the first situation, and then we have some sort of acute angle in the second situation. But if we think about the quarters, the height of the quarters is the same in either situation. So the one thing that we have to understand is we don't want to look at the slant height of an oblique cylinder. We still want to focus on the vertical height or the distance between the two base shapes. So now if we're going to find the volume of this oblique cylinder, we start with our basic formula. Volume equals area of the base times the height of the object. Once we have that, we need to find the area of our base shape, which is a circle. So we have 4 squared pi is the area of our circle. And then we need to multiply times the height of the object. And in this case, our height is the vertical distance between the two bases of 12. And it is not the slant height of 13. Okay, so we actually want to not look at that value and use only the vertical distance or the height between the two bases. Now, worst case scenario, if you have a situation where this height is something that you don't have, we want to go right back into Pythagorean theorem to help you solve for that missing height if you don't have it. So now we have 16 times 12 pi, and then we're finishing up, which gives us a volume of 192 pi centimeters cubed. Now, what happens if we don't have a full cylinder? If we don't have a full cylinder, we're still going to work with our volume the way that we would in a traditional sense. Area of the base times the height. But then we just want to understand that we don't want all of that volume. We want a proportion of that volume. So we want x over 360 of our volume. And now we can plug in all the information that we know to get our answer for this situation. Now, how much volume do we want? We're missing 60 degrees of the volume, so we need 300 degrees of the volume. So we have 300 over 360. That's the proportion that we're going to keep. Our base shape is still a circle. So we have our radius of 7 squared pi, and then we have the height of our cylinder at 13. So finishing up here, we have 7 squared times 13, which is 637 pi. We're going to multiply that times 300, and then divide by 360. Okay, and we're going to get a fraction here. We can look at it in decimal form. We've got 530.83 pi. And then if we want to finish this out, we could multiply by pi, or 3.14, and get a rounded answer of 1,669 centimeters cubed. And that's rounded to the nearest whole centimeter. Okay, that completes our lesson for today. Okay, your homework that you have in Schoology, AV4 Lesson 2, and make sure you send me a message if you have any questions. Thanks.